The worst case which can happen in an industrial production is breakage of a drag chain. This can happen by a block or by a misalignment of the trough or from snow or whatever. Since many years we have our ECP, the push-pull detection system, which measures the force and which switch off the machine in case the force increase or decrease on a fixed force level. For moving a chain you need force, push force and pull force. And you're able to imagine that on this side, far away from the radius, you need a high force for bridging the friction between the upper trough and the lower trough. And if the chain is on this side, there is only the radius, there is no friction, and lower force is needed. So in case of using a push-pull detection system like ECP for preventing bigger effects in case of blocks or in case of misalignments, then it is important to know where the trolley is to adjust the force limits when the system will be switched off. This year we present the ECPR system, which is an extension of the existing system with a second module which reads the information about the position of the trolley out of the PLC or out of the PCOR server or many other ways. And by that it is possible to define the right force limit for each position of the chain to detect all unexpected events and to switch down the machine and to prevent unexpected downtime and higher costs. This is an antenna. This antenna is a big box. It's connected to the floating tow arm, for example, of a container crane. This is a beacon, a transmitter. This beacon sends his position continuously wireless to this antenna. By knowing that, this antenna calculates the precise position internally and transmits this information by Profinet to customer's PLC and to our ECPR system. Basically, it creates the position information for the ECPR system. But on the second channel, this system is so precise and the manufacture of this system is well known in the crane business that it is not necessary for the crane manufacturer to build another positioning system on the other side on the crane, and by that the customer will save around 4 to 6 days installation time by using the ECPP system. The second generation of ECW, ECW06, integrated in a crossbar, measures the lifetime of a gliding drag chain system. During operation, the sidebars will pass away, and by that this surface will be scrubbed away, and below this surface there are loops, and these loops will be disconnected by wear. We do it in 4 steps so that it is possible to give the lifetime of the chain in 25% steps. The special feature of this new sensor is that the integrated LTE modem is connected directly to the internet, so no more hardware is needed. This is the new ECI sensor for integrated lifetime measuring of an energy chain, and in this case it is the first sensor which is also available for unsupported chain applications. The sensor itself simulates a second couple of links, and we measure the clearance between nut and bolt from the main link here on this side, and if this clearance becomes bigger, then the sensor inside detects this clearance, and we measure it in percentage steps so that we are able to give a clear lifetime or a clear rest lifetime of this system. In the sensor integrated is a so-called LoRa module, which is a wireless transmission module to this receiver, which can be connected with the ICOM Plus module. The system is able to handle several chains, and inside the ICOM Plus module, this information will also convert it into a web page, which you can see here. Here we show the energy chain, and here we show the status of the system. Here you can see the rest lifetime in days, which is given to the customer for planning maintenance works. This system allows to extend the lifetime of the chain to the maximum lifetime. On the other hand, it prevents unexpected downtime by unexpected chain breakage. This is the new ECW02 box. This box is able to monitor up to 4 smart IGUS bearings, and the condition of the bearing is to see on the LEDs, and the condition of the bearing will be transmitted by LoRa to the ICOM Plus module, and with the internal web server it is possible to monitor status of the bearings, in this case 4 bearings continuously. So I will simulate a failure, and now you see one of the sensors, one of the bearings reached the end of the lifetime, and this information is usually as early that a maintenance break is plannable.